Be learning about AWS Cloud Computing. Let's get started. Alright, so today, as I said, we're going to be learning about AWS Cloud Computing. So the first section, what is cloud computing? The definition of cloud computing is the on-demand delivery of compute power, database storage. Sorry for that. Let's get back to where we were. Alright. AWS cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. AWS started cloud computing back in 2006, where they sold IT infrastructure services to businesses as web services. This provides a simple way for customers to access servers, storage, databases, and a broad set of application services all over the internet. A cloud services platform, such as AWS, owns and maintains the network-connected hardware required for services, while you, the user, provision and use what you need. The cloud helps build and run applications. The cloud can also be used for the deployment and management of these applications. It is available to hundreds of thousands of customers across 190 countries. It provides powerful resources at low operational costs. Classically, provisioning services is like a Goldilocks problem where it's hard to get it just right. However, with AWS, you can elastically scale up or down to meet your needs. Cloud benefits. So the cloud will give you the ability to deliver innovative new features to the market much quicker and focus on adding differentiated value to your product. This makes new ideas feasible that were once out of reach. Experimentation becomes fast and low risk, and you can adjust your cloud usage to fit any workload. It also helps businesses serve their customers globally without the need for expensive time-consuming expansion. The cloud can deploy web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, and more. The cloud also connects to personal infrastructure by a private dedicated connectivity. Here are some additional cloud benefits. Trading capital expense for variable expense. You can benefit from massive economies of scale. You can stop guessing about capacity. You can increase speed and agility. You can stop spending money running and maintaining data centers. And you can go global in minutes. So trading capital expense for variable expense is where you pay for only what you consume and you only pay when you're consuming it rather than paying a standard monthly fee. This can also help you benefit from massive economies of scale by having a lower variable cost and thus achieving higher economies of scale, leading to lower prices. You can stop guessing about capacity as you can access as much or as little of the cloud as you need, and then scale up or down when necessary with only a few minutes' notice. You can increase your speed and agility by reducing the time it takes to make certain resources available. This causes a large increase in agility due to cost and time to experiment becoming extraordinarily lower. You can stop spending money running and maintaining data centers, as the cloud takes care of that, and you only have to focus on your own customers. You can go global in minutes by deploying your application in multiple regions around the world extremely quickly in just a few simple steps. This means you can provide lower latency or delay before transfer of data and a better experience for your customers at a small cost. Total cost of ownership. So total cost of ownership reduces the need to invest in large capital decisions. This provides you a pay-as-you-go model that allows you to invest in the capacity that you need and use. TCO calculators also allow you to estimate the cost and savings by switching to the cloud. Calculators also modify assumptions that best meet your business needs. The calculator also provides directional guidance on possible savings by switching to the cloud. The tool is built on an underlying calculation model, and therefore it generates a fair assessment of value that a customer may achieve. However, it's important to note that the TCO calculator results is only used as an approximation. As you can see on the diagram on the right, This is an example of how much a user could save by switching to AWS as compared to using and maintaining data centers. So here's a quick video that summarizes cloud computing, and it will be linked below. Next, let's talk about the types of cloud computing. So there are several different models of cloud computing, and it allows different amounts of control of web services. There are three main types: infrastructure as a service, platform as a service, and software as a service. As you can see on the diagram on the right, it shows what each type of model of cloud computing allows you to control and the service provider to control. So on-site is run all by the user. Iaas is a 50-50 split. Platform as a service has the user manage applications and data, while the service provider manages everything else. And software as a service is where the service provider manages everything. So let's talk about each. Infrastructure as a service contains the basic building blocks for cloud IT. It typically provides access to networking features, computers, virtual or dedicated hardware, and data storage space. It provides the highest level of flexibility and management and is the most similar to existing IT resources. It also allows for instant computing infrastructure. Next, platform as a service. This removes the need for organizations to manage the underlying infrastructure, usually the hardware and operating systems. It allows you to focus on the deployment and management of applications, and it helps business owners be more efficient. This disregards any human concern over resource procurement, capacity planning, software maintenance, patching, and more. This also combines hardware and software components. Lastly, software as a service. This provides customers with a completed product that is run and managed by the service provider. SaaS, or software as a service programs, are usually referred to as end-user applications. There is no user concern about service maintenance or how infrastructure is managed. The user only concerns himself with how they will use the software. For example, a web-based email to send and receive emails without having to manage any feature additions are an example of software as a service. Here's a video discussing Iaas versus Paas versus Saas. Next, how to deploy cloud infrastructure easily. There are 4 key areas to make deploying cloud infrastructure easy. Highly trusted global infrastructure, providing broad compatibility with all popular workloads, fast and secure private networking, and tools to control access to all cloud resources. So first, highly trusted global infrastructure. This is designed for high security and availability needs of the large enterprises. It offers capabilities that restrict unauthorized access or usage without sacrificing any flexibility, and it provides a backup for all features. Next, it provides broad compatibility with all popular workloads by spinning up virtual servers, hard drives, databases, networks, and more. The cloud is also easily set up using virtual servers using Linux or Windows. Fast and secure private networking. You can provision a private section of the AWS cloud that you define and retain control of. This is done through simple IP networking. The cloud environment becomes an extension of your on-premises environment, and it uses a standard pipe that encrypts data when it moves from your environment to the cloud. More data creates dedicated network connection from your existing data centers to AWS. This will give you a predictable network performance increase by bypassing the public internet. Lastly, tools to control access to all cloud resources. This creates and manages users and integrates them with your existing identity systems. This will allow for greater flexibility to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and security of AWS. Next, let's discuss some methods. So the cloud-based applications are fully deployed in the cloud. Applications in the cloud are created in the cloud. Or another way they're used is by being migrated from existing infrastructure to take advantage of benefits. The cloud-based applications can be built on low-level infrastructure and can also use higher services that provide detachment for management, architecting, and scaling goals. Another method is hybrid, and this is a way to connect infrastructure and applications. This connects cloud-based resources and existing resources. A common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while connecting their cloud resources to their internal system. This will allow users to run applications in both the cloud and on-premises, and you can access AWS wherever necessary. Next, we have on-premise. So on-premise is referred to as the private cloud, and it uses virtualization and resource management tools. On-premises deployment leads to the inability to receive cloud computing benefits, however. This is used to provide dedicated resources. Typically, this is the same model as previous IT infrastructure, and it uses application management and virtualization technologies to attempt to increase resource usage. Here is a video that discusses the cloud model versus the hybrid versus the on-premise. Next, let's discuss AWS's security. AWS's infrastructure installs safeguards to protect privacy. Data is kept in highly secured data centers. This manages dozens of compliance programs. Segments of compliance have already been completed. This has the highest security without the user managing their own facility. It also saves money at the same time, and you can help scale your security with your AWS cloud usage, and maintain security regardless of cloud size. Here's a video discussing AWS security. Next, let's talk about the services that AWS can provide. First, we have AWS Analytics Services. These are a set of services that handle every step of the analytics process. The services are powerful, flexible, and yet simple to use, and this enables organizations to put their unorganized data to work efficiently. Here are some example services: Elasticsearch, Amazon Kinesis, Amazon Redshift, and Amazon Athena. Elasticsearch is an open-source search and analytics engine used to log analytics, real-time application monitoring, and user-click analytics. Amazon Kinesis allows you to absorb, buffer, and process streaming data to find insights promptly. Amazon Redshift can ask questions and combine exabytes or a 10 to the 18th byte of organized and disorganized data across your data warehouse. Operational database and data lake. A data lake, for those that don't know, is a centralized repository that allows you to store all of your structured and unstructured data at any scale, using a language called Standard Query Language, or SQL. Amazon Athena is an interactive question service that makes it simple to analyze data in Amazon Edge 3 using SQL. AWS Compute Service. So, AWS offers multiple services that can deploy, run, and scale applications as virtual servers, containers, or code. Examples include Amazon EC2, Amazon Lightsail, Amazon Elastic Container Services, and more. Amazon EC2 obtains servers quickly and inexpensively. Amazon Lightsail creates a virtual private server, or a VPS, on AWS. And Amazon Elastic Container Services runs in Docker containers. Docker containers contain software that are in standardized units known as containers. Containers package everything a software needs to run, including libraries, system tools, code, and runtime. AWS Database Services. These are necessary databases for applications such as managed relational, non-relational data warehouse, in-memory data store, and graph databases. Example of database services include Amazon DynamoDB and Amazon Relational Database Service, or RDS. Amazon DynamoDB is a fast and flexible database service for any workload. This provides you the way to pay for only what you utilize. The key value databases that delivers nearly instantaneous single-digit performance at any scale. It is built to handle internet applications, and it is a fully managed service that handles more than 1 trillion requests per section. Amazon Relational Database Service, or RDS, is a relational database service with 6 well-known database engines and can be set up, operated, and scaled in a few steps. Next, let's talk about AWS Developer Tools. So AWS Developer Tools contains code and automatically creates, evaluates, and deploys applications. It is a set of services that quickly and carefully deliver software. These services store and hold control over your application's source code. It is used for constant integration, continuous delivery, infrastructure as code, and monitoring. The following are some examples: AWS Code Pipeline, AWS Cloud Development Kit, and AWS Code Deploy. AWS Code Pipeline can create an end-to-end software release workflow using services. It is a continuous delivery service that automates the release of pipelines in order to have fast and reliable applications as well as infrastructure updates. It effectively and efficiently delivers features and updates. AWS Cloud Development Kit, or AWS CDK, is an open software development structure to define your cloud application resources using known programming languages. This applies cloud applications and can be a challenging process that requires you to perform manual actions, write custom scripts, maintain templates, or learn domain-specific languages. AWS CDK utilizes familiarity and expressive power programming languages to modeling your own applications. Next, AWS Code Deploy. This is a tool that installs applications and updates servers. It lowers workload on developers and quickens releases of new products and features. Code Deploy makes it simple for users to rapidly release new features, help dodge downtime during application deployment, and deal with the complexity of updating applications. Positives include automated deployments, minimized downtime, centralized control, and the fact that it is easy to adopt. Next, we have AWS Management Tools. These allow you to provision, monitor, and set forth your cloud environment. You can maintain stable control without restricting your development speed. AWS CloudWatch, CloudFormation, and System Manager are some examples. AWS CloudWatch is a service that was built for developers, system operators, site reliability engineers, or SRE, and IT managers. CloudWatch provides information and insights to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get an allied view of operational health. This gathers monitoring and operational data in the form of logs, metrics, and events, providing you with a linked view of AWS resources, applications, and services that run on AWS and on on-premise servers. AWS CloudFormation provides a common language to supply important assets in the cloud. Provisions can be automated and sent over and over again. This models infrastructure using a simple text file. AWS Systems Manager allows full control of the structure of AWS. It automates tasks needed for smooth operations, helps guarantee security and compliance, and it can detect problems quickly. Next, AWS Networking and Content Delivery Services allow you to isolate your cloud infrastructure, scale request handling capacity, and connect physical network to private virtual network. The networking products would work together to meet requirements. Elastic Load Balancing is an example. This coordinates with Amazon Virtual Private Cloud, VPC, to give networking and security features. It distributes application traffic among different services. It handles traffic in one or multiple availability zones or data centers, and it improves scalability or adjustability of applications. Next, AWS Storage Services. This is a reliable, secure, and adjustable location for your data. AWS offers a wide variety of cloud storage services to support both application and archival compliance requirements. Archival requirements are the dates when things can be archived or stored away. One can choose from different options to build the base of your cloud storage management solution. In AWS, the different types of storage services include object storage, file storage, block storage, backup, data transfer, and edge computing and storage. Here is a video discussing all of the AWS Web Services that we covered. That will be it for cloud computing. Thank you everyone for watching. All these videos that have been shown in the presentation will be linked below. Thank you.